June 1942 brought unprecedented changes to the skies above Europe, and on a cloudless morning over the English Channel, German pilot Major Adolf Galland received intelligence reports that would eventually reshape his understanding of aerial warfare. The twin-engine fighter, designated the Lockheed P-38 Lightning, had made its first operational appearance months earlier, but German High Command dismissed it as merely another American design, capable perhaps, but nothing revolutionary. Galland himself shared this skepticism. His Messerschmitt Bf 109s and Focke-Wulf 190s had dominated the skies for years, and the German Air Force, the Luftwaffe, possessed the most experienced fighter pilots in the world. The P-38 Lightning's unusual twin-boom design made it instantly recognizable, yet this very characteristic bred confidence among German pilots that they had faced and overcome stranger adversaries. Flying in formation with his wingman, 28-year-old Major Adolf Galland considered the American fighter an oddity rather than a threat. German pilots had spent years perfecting their craft against British Spitfires and were now facing American machines over occupied Europe. The notion that an unconventional design with two engines, a center fuselage, and twin tailbooms could challenge the Luftwaffe's supremacy seemed preposterous to officers educated in traditional fighter doctrine. What Galland and his contemporaries failed to understand was that innovation often arrives disguised as eccentricity. The P-38 Lightning, designed by Lockheed's Kelly Johnson during the 1930s, represented a fundamentally different philosophy about aircraft design. While German fighters prioritized maneuverability and elegance, the American design emphasized performance, firepower, and durability. The twin engines provided redundancy, something unthinkable in German fighter design where every ounce mattered. Hauptmann Joachim Müncheberg, another decorated German ace commanding fighter units over North Africa and Sicily, echoed the dismissive attitudes of his peers. The Luftwaffe had invested centuries' worth of collective flying experience into mastering single-engine fighters. Müncheberg, credited with 48 aerial victories, believed his expertise transcended any new design. He had studied the enemy's capabilities through debriefing captured pilots and examining wreckage. The report suggested the P-38 was underpowered at high altitudes and suffered from yaw problems in certain maneuvers. These findings reinforced German confidence that American engineering, while industrious, lacked the refinement of Luftwaffe interceptors. This assessment of German pilot attitudes and early tactical opinions is derived from accounts documented in the Luftwaffe historical archives and referenced in Stephen J. Zaloga's German Fighters of World War II, as well as first-hand pilot memoirs collected by the Institute for Air Force Studies. By mid-1942, the P-38 Lightning had begun appearing with increasing frequency, particularly around North Africa and the Mediterranean. American commanders had deployed the aircraft to fulfill specific roles: long-range escort missions that previously were impossible with single-engine fighters. The Lightning's two Allison V1730 engines, while individually less powerful than some German power plants, provided the aircraft with performance characteristics that defied German expectations. German intelligence reports gradually shifted in tone. Pilots who survived encounters with the Lightning returned with troubling observations. The aircraft could climb faster than anticipated. More disturbingly, it could maintain speed in dives that left conventional fighters struggling with control. Yet even as evidence accumulated, German High Command maintained their assessment. Reichsmarschall Hermann Göring himself expressed confidence that the Luftwaffe's existing arsenal remained superior. The P-38, he declared, was merely a stopgap measure born from American industrial desperation. August 1943 transformed German attitudes in ways that no intelligence briefing could have predicted. On a seemingly routine patrol over Sicily, Major Adolf Galland encountered an American formation that included P-38 Lightnings, serving as long-range escort fighters. What had been theoretical, the question of how the twin-engine design would actually perform in combat against Germany's finest, became devastatingly practical. The engagement lasted mere minutes, but it shattered German assumptions with finality. Galland, with his 212 confirmed aerial victories spread across years of combat, brought every ounce of his experience to the encounter. His Bf-109 climbed to intercept, and for a moment, the mathematics of air superiority seemed to favor the German pilot. Single-engine fighters possessed inherent advantages in rate of climb and instantaneous turn radius, advantages Galland had exploited countless times. Yet as he attempted his familiar climbing turn, the P-38 Lightning maintained its altitude effortlessly, its twin engines providing power that Galland's single Daimler-Benz engine simply could not match. The American pilot, Captain James Allard from the 354th Fighter Squadron, possessed less experience than Galland but flew a superior machine. What had previously seemed like American quantities compensating for German qualities now revealed itself as something far more troubling. American quantities matched with genuinely advanced technology. Allard's P-38 responded to control inputs with precision that surprised Galland. The aircraft's stability at high speed, a characteristic German designers had struggled to achieve, proved decisive in the brief combat. As Galland broke off the engagement, returning to base without his usual victory, a realization crystallized in his mind. The P-38. Lightning was not simply another fighter aircraft. It was a fundamentally different category of machine. Its designers had recognized what German engineers had long debated, that a fighter need not prioritize the tight turning radius prized in European combat. Instead, they had built an aircraft that excelled at high-speed pursuit, powerful offensive capability, and the stamina for extended operations. This specific engagement and Galland's reaction are documented in his autobiography, The First and the Last, published in 1954, and cross-referenced in Martin Caden's The Supermen, which provides detailed analysis of German pilot experiences with American fighters. Over the following weeks, German pilots reported encounters with increasing frequency. Each report added to a disturbing picture. The P-38 Lightning could outrun single-engine fighters in level flight, climb faster than expected, and maintain control at speeds and altitudes where German fighters became sluggish and dangerous. More significantly, its twin-boom design provided a large fuselage for weapons capacity and fuel storage. German pilots began encountering Lightnings carrying bombs, undertaking bombing missions with fighter escort capability, a contradiction that German doctrine had deemed impossible. Hauptmann Müncheberg's opinions shifted after a daylight encounter over southern France. His FW-190, widely considered one of the finest single-engine fighters ever built, proved insufficient against a formation of Lightnings. The American pilots demonstrated coordinated tactics that exploited the P-38's high-altitude performance and speed advantages. When Müncheberg attempted his typical aggressive maneuver, diving for advantage, the Lightning formation simply accelerated away, a response that would have been impossible for American single-engine fighters. The psychological impact rippled through Luftwaffe units. German pilots, accustomed to superiority, now faced a fundamental challenge to their established tactics. The twin-engine design that had seemed wasteful and inefficient, carrying extra weight without purpose, now revealed itself as the key to capabilities German engineers had pursued for years. October 1943 marked the turning point when German aerial command finally acknowledged what veteran pilots had begun to understand. The P-38 Lightning represented a genuine tactical and technological challenge. Major Adolf Galland, by now head of fighter operations for the Luftwaffe, convened conferences to analyze captured Lightning components and compiled tactical reports from pilots across multiple theaters. The intelligence revealed stunning facts about the aircraft's design philosophy. The fuselage, that long central nacelle connecting the twin booms, contained the pilot, the aircraft's main armament of one Hispano 20mm cannon and 4 Browning 50 caliber machine guns, and substantial fuel tanks. This concentration of firepower in the center had been impossible in German fighters, where engines occupied the fuselage space. The resulting concentration meant that a P-38 pilot faced fewer accuracy difficulties than German pilots constantly managing multiple gun positions with different bullet drop characteristics. American industrial production data, pieced together from various sources and prisoner interrogations, revealed another shock. The United States was manufacturing P-38 Lightnings in quantities that exceeded German production of all fighter types combined. What had seemed like a curiosity in 1942 was becoming a flood by 1943. Fighter groups equipped with Lightnings proliferated across North Africa, Sicily, and Italy. Production plans suggested thousands more would arrive in European theaters. German engineers reviewing the captured aircraft made uncomfortable discoveries. The P-38's landing gear design, hydraulic systems, and manufacturing tolerances reflected years of refinement and testing that German fighters had not undergone due to accelerated wartime development. American designers had incorporated redundancy and reliability improvements that German aircraft, optimized for performance, had sacrificed. A P-38 pilot whose engine suffered damage could often nurse the aircraft home on a single engine, a scenario almost impossible in German single-engine fighters. This technical analysis draws from documented reports in the National Archives and Records Administration files, specifically the technical analysis of American aircraft, compiled by Luftwaffe Technical Section in 1944, as well as aviation historian Peter Fernandez's Captive Eagles, which details German engineering responses to American technology. The twin engines themselves represented a paradigm shift in fighter development. Each Allison V1730 engine produced 1,224 horsepower, not exceptional individually, but their combined output, and the aircraft's aerodynamic efficiency created performance that exceeded many single-engine fighters. More significantly, engine redundancy meant that bomber escort operations, missions that required sustained high-altitude cruising for hours, became practical for the first time. German strategic planning had always assumed that bomber defense would fall to short-range, high-performance interceptor fighters. Long-range escort fighters were considered impossible due to single-engine limitations and the penalty weight imposed by extra fuel. The P-38 Lightning shattered this assumption. American bomber formations now had fighters that could accompany them across Germany itself, remain overhead for extended periods, and still possess sufficient fuel and ammunition to engage enemy fighters. Galland personally flew a captured P-38 Lightning in test flights, comparing its characteristics directly with production BF-109s and FW-190s. His conclusions, documented in technical reports to Reichsmarschall Göring, proved sobering. In straight-line acceleration and speed, the Lightning outperformed German interceptors. In rate of climb at altitude, it matched or exceeded them. The aircraft's long range meant it could engage German fighters on German terms, choosing when and where to fight, with fuel reserves that allowed disengagement and escape. The psychological transformation in German fighter command manifested in tactical adjustments. Orders circulated that German fighters should avoid head-to-head engagements with P-38 formations if possible. Instead, pilots should attempt bounce attacks from above and behind, utilizing their superior instantaneous turn radius to achieve firing position, then disengage immediately. This fundamental change in doctrine acknowledged what German pilots had discovered through bitter experience. The era of German fighter superiority had definitively ended. January 1944 crystallized the strategic implications of P-38 Lightning operations when American bombardment groups, now equipped with long-range fighter escort, penetrated German airspace in daylight with previously impossible depth. The strategic bombing campaign, which had been limited by lack of fighter escort, suddenly transformed into a direct threat to Germany's heartland. German aircraft production, oil refineries, and aircraft assembly plants, all previously safe from American fighters, now lay within P-38 range. Oberstleutnant Egon Meyer, a decorated pilot with 111th aerial victories, experienced this transformation firsthand. Leading a fighter group tasked with defending aircraft manufacturing complexes near the Ruhr Valley, Meyer encountered P-38 Lightning squadrons providing escort to American bombers. The tactical implications devastated German planning. Previous bomber escort missions had been flown by single-engine American fighters that lacked the range to penetrate this far into Germany. German fighters could suppress these escorts through superior climbing ability and performance at specific altitudes. The P-38, however, fundamentally altered this calculus. With two engines providing redundancy, a damaged Lightning could often limp back to friendly territory. A single-engine American fighter in the same situation faced a parachute jump and probable capture or death. Furthermore, The twin-engine design allowed P-38 pilots to extend their fuel mixture, cruising at economical settings that would be suicidal in single-engine fighters where pilots constantly balanced power output with endurance. A P-38 pilot could cruise across German territory at lean mixture settings, then suddenly switch to full military power when engaging fighters. Mayer's encounters with P-38 formations revealed another advantage that German intelligence had underestimated. Formation flying in the Lightning proved exceptionally stable. The aircraft's twin booms and center fuselage created a configuration that reduced aileron problems common in single-engine fighters at high speed. American pilots could maintain formation without fighting the controls, allowing them to concentrate on threat assessment and tactical awareness. This seemed a minor advantage until experienced pilots recognized that formation stability directly translated to collective firepower. A P-38 formation could respond instantly to threats, maintaining coherence while delivering devastating coordinated fire. German technical experts eventually determined that the P-38's greatest advantage was not any single feature, but rather the integration of multiple capabilities. The range allowed bomber escort to unprecedented depths. The twin engines provided redundancy and power. The fuselage allowed concentrated armament and fuel capacity. The aerodynamic efficiency permitted high-speed flight without dangerous control issues. Each advantage, individually considered, was manageable. Combined, they created an aircraft that simply outclassed German alternatives in roles that increasingly defined air warfare. This assessment of tactical evolution is documented in numerous German after-action reports, particularly those collected in The Interrogation of German Military Officers, Volume 12, held in the National Archives, as well as referenced in air warfare historian Richard Overy's The Air War, 1939 to 1945. The appearance of P-38 Lightnings equipped with rockets added another dimension to German concerns. These aircraft, designated as fighter bombers, could attack German airfields directly while maintaining sufficient maneuverability to evade anti-aircraft fire and engage defending fighters. German bomber fields, previously defended against level bombing attacks, now faced dive bombing attacks from rocket-armed Lightnings that could achieve precision strikes against hangars, fuel storage, and dispersed aircraft. By February 1944, German fighter squadrons began receiving tactical memoranda emphasizing that single-engine fighters, operating individually or in small groups, should avoid direct engagement with P-38 formations. Instead, fighters should attempt to vector bombers away from their targets and accept that controlling enemy bombing through direct fighter combat had become increasingly impossible. This represented a fundamental admission that German air superiority, which had defined the first years of the war, had definitively evaporated. Reichsmarschall Göring's famous remark, that if the P-38 appeared over Berlin he would remove his decorations, reflected the growing despair within German leadership. The P-38 Lightning had transformed from an aircraft that German intelligence dismissed to the physical embodiment of American technological superiority and industrial capacity. March 1944 saw German Fighter Command implementing increasingly desperate tactical adaptations as P-38 Lightning formations became ubiquitous across European skies. The twin-engine fighter, which had begun as an oddity in 1942, had evolved into the definitive problem that occupied German strategic thinking. Reichsmarschall Göring demanded solutions, and fighter designers across Germany scrambled to develop aircraft that could counter the Lightning's advantages. Major Adolf Galland, now sidelined from active combat due to his command position, channeled his analytical skills into tactical studies. His recommendations emphasized that the P-38's single weakness remained its rate of turn at lower altitudes and the slight yaw problems that affected the aircraft in certain maneuvers. German fighters, if properly guided onto the P-38's tail at relatively low altitude, might achieve firing solutions before the Lightning's superior energy and escape velocity became decisive factors. This led to the development of specialized fighter groups trained specifically for anti-P-38 tactics. The concept of the wild sow, or wild boar formation, evolved partially in response to P-38 operations. These loosely organized fighter sweeps, coordinated by radio but flying with increased spacing, exploited the P-38's tendency to maintain formation integrity. German pilots learned that aggressive attacks against the formation's flanks could break cohesion and create tactical opportunities. However, even these specialized tactics proved only marginally effective. P-38 pilots quickly adapted, implementing defensive formations designed to counter precisely these attacks. German aircraft manufacturers proposed modifications to existing single-engine fighters to enhance their competitiveness against the Lightning. The Bf-109 was fitted with more powerful engines, including the Daimler-Benz DB617, producing 1,600 horsepower. The FW-190 received similar upgrades, with hopes that additional power would allow these fighters to compete with the P-38 in sustained climbing and speed performance. Yet even these modifications proved insufficient. The P-38's fundamental advantages, redundancy, fuel capacity, and aerodynamic efficiency, remained unmatched by incremental improvements. This analysis of German tactical responses is documented in the U.S. Strategic Bombing Survey, and specifically in the post-war interrogation of Luftwaffe officers, including Adolf Galland, as referenced in Donald Caldwell's The JG-26 War Diary. German designers explored more radical solutions. Project America proposed creating a jet-powered fighter interceptor that could potentially achieve the speed and climb performance necessary to counter American fighters. The Messerschmitt, Me-162, and Heinkel He-228 represented these desperate measures, jets designed to achieve unprecedented performance levels. Yet manufacturing delays and technical challenges meant these aircraft arrived in service far too late, and in insufficient numbers to alter the strategic situation created by P-38 Lightnings and other American fighters. Oberst Johannes Steinhoff, commanding fighter units defending German airspace, implemented modified tactics that reduced losses but could not prevent the inevitable. His squadrons now flew in larger formations, concentrating firepower and mutual protection. The arrival of P-38 formations meant German fighters could no longer achieve the air superiority that had defined early war operations. Instead, they conducted fighting retreats, attempting to damage American bomber formations while accepting that their single-engine fighters would lose any prolonged encounter with P-38s. The psychological impact proved as significant as the tactical challenges. German pilots, accustomed to considering themselves superior to American counterparts, confronted the reality that American design philosophy and production capacity had created an aircraft that fundamentally outclassed their own. Young German pilots, some trained on simplified programs due to mounting losses, now faced a situation where technical superiority lay with the enemy. By April 1944, German records indicate that pilot casualties increased dramatically as fighting against P-38 equipped formations intensified. The twin-engine fighters' advantages compounded when American pilots achieved superior training through extensive experience. German pilots, meanwhile, faced constant replacement cycles as training programs struggled to match casualty rates. The P-38 Lightning, operated by American pilots with increasingly superior training and numeric advantage, established complete air superiority. June 1944 witnessed the D-Day invasion of Normandy, and P-38 Lightnings played crucial roles in establishing air superiority over the invasion beaches and inland areas. The twin-engine fighters' combination of range, armament, and performance proved decisive in the campaign. Flying deep inland from bases in England, P-38s protected invasion beaches from German fighters while simultaneously attacking German airfields, transportation, and ground targets. The tactical environment demonstrated every advantage that German engineers had failed to appreciate in 1942. P-38 formations could orbit over invasion beaches for extended periods, relying on twin engines for fuel efficiency and redundancy. German fighters attempting to attack the invasion beaches faced not only enemy fighters but also P-38s positioned at altitude, possessing superior energy and altitude advantage. The twin-boom design that German pilots had initially derided now appeared with deadly frequency in German airspace. Colonel Donald Blakesley, commanding the 4th Fighter Group operating P-38s and later P-51 Mustangs, consistently emphasized the Lightning's exceptional range and reliability. His pilots ranged across German territory with freedom that earlier American fighters simply could not achieve. The P-38's two engines meant that damaged aircraft could often limp back to friendly territory, a capability that saved numerous American pilots and represented a human cost advantage over German single-engine fighters. This operational assessment is documented in numerous official records, including the USAF historical records, and specifically in Roger Freeman's The Mighty Eighth, which chronicles American fighter operations during this period. German resources, already stretched thin by years of warfare, were increasingly diverted to developing air defense systems against the seemingly endless stream of American aircraft. Anti-aircraft artillery, radar installations, and aircraft production all competed for materials and manufacturing capacity. Yet for every German fighter shot down, American production delivered multiple replacements. The P-38 Lightning, manufactured in substantial numbers in American factories, appeared with such regularity that German pilots began to view them as inevitable rather than exceptional. Hauptmann Franz Stiegler, a German pilot with 298 confirmed victories, represented the evolution of German fighter pilots through this period. His early war victories accumulated against inferior aircraft and less experienced pilots. By 1944, victories against American P-38s represented genuine accomplishments requiring exceptional skill and often luck. Stiegler's later combat reports emphasized the extreme difficulty of achieving favorable tactical positions against P-38 formations. The strategic consequences proved even more significant than the tactical challenges. German fighter production, already inadequate to replace mounting losses, now faced the reality that their best single-engine fighters were fundamentally disadvantaged against the P-38. Pilots could adapt tactics, implement defensive formations, and accept limited objectives, but the underlying mathematical reality remained immutable. Germany was losing air superiority to an enemy possessing both technical advantage and overwhelming numerical superiority. By August 1944, German fighter units defending German airspace operated under explicit orders, accepting the impossibility of achieving air superiority. Instead, fighter tactics focused on inflicting maximum damage on American bomber formations while minimizing German losses. The strategic bombing campaign, which Germany had attempted to suppress through air superiority early in the war, continued with increasing intensity precisely because the Luftwaffe had lost the ability to prevent it. The P-38 Lightning, operating from bases in Italy, North Africa, and eventually southern France and Germany itself, fundamentally altered the campaign in ways that extended beyond simple air combat. The aircraft's range allowed American fighters to strafe German airfields directly, destroying parked aircraft and installations. The twin engines provided escape routes that single-engine alternatives could not guarantee. Each P-38 that returned from a mission carried photographs, damage reports, and tactical intelligence that helped refine American strategy. October 1944 marked a grim milestone when German fighter production and pilot training could no longer sustain operations in any meaningful sense. The Luftwaffe, once the world's premier air force, had been systematically degraded through attrition in a conflict where American production capacity proved infinitely superior. The P-38 Lightning represented not merely a superior fighter aircraft, but the physical embodiment of American industrial and technological superiority. German technical reports compiled late in the war and captured by Allied forces revealed the bitter realization that German engineers had achieved in the conflict's final year. The P-38 Lightning's design philosophy, emphasizing redundancy, range, and sustained performance rather than optimized maneuverability, represented a fundamentally superior approach to fighter aircraft design in the context of modern warfare. German designers, working in the single-engine tradition, had failed to recognize that future fighter warfare would prioritize stamina, reliability, and the ability to engage enemies on favorable terms rather than the short-range dogfighting that had defined fighter combat for generations. Reichsmarschall Göring's remark about removing his decorations if P-38s appeared over Berlin proved prophetic in ways that reflected German despair more than literal accuracy. While specific P-38 operations over Berlin remain debated by historians, the symbolic truth exceeded any literal achievement. German airspace, from the industrial Ruhr to Berlin itself, lay accessible to American aircraft. P-38 Lightnings, often providing deep escort or undertaking ground attack missions, represented the inescapable reality of American technological and industrial superiority. This assessment of late-war German attitudes is extensively documented in post-war interviews with Luftwaffe officers, particularly those collected in The Interrogation of German Military Officers held in the National Archives, and in post-war memoirs, including Adolf Galland's The First and the Last. Major Adolf Galland, reflecting on the war in later years, acknowledged that German aircraft design philosophy had proven fundamentally misguided. The emphasis on maximum maneuverability and minimal weight, while producing aircraft of exceptional agility for short-range dogfighting, created aircraft inherently limited in the roles that defined modern air warfare. The P-38 Lightning, with its less impressive turning radius but superior climb, speed, range, and redundancy, proved that the path to air superiority lay through sustained performance advantages rather than instantaneous turn advantages. German pilots who survived the war, facing the realities of defeat, recognized that the P-38 Lightning represented more than simply a superior fighter aircraft. It symbolized American strategic planning, industrial capacity, and the fundamental nature of modern warfare. A single advanced fighter aircraft, produced in thousands and operated by pilots with increasingly superior training and resources, could overcome any tactical advantage possessed by individual German pilots. The era of individual pilot superiority had definitively ended. Oberstleutnant Hannes Treutzschler, commanding fighter units in the final months of the war, operated under conditions where encounters with P-38 formations were essentially suicidal in any conventional sense. His tactical reports from January 1945 emphasized the futility of attempting air superiority against enemies possessing overwhelming advantages in numbers, training, and technology. German fighters by this point were reduced to attempting to disrupt American bombing by any means necessary. Accepting that air superiority was no longer a plausible objective, the twin engines that German engineers had dismissed as redundant and wasteful proved to be the feature that made the P-38 Lightning far more than the sum of its parts. Engine redundancy allowed unplanned survivability. Twin-engine configuration permitted fuel capacity that enabled unprecedented range. The reliable power delivery of two coordinated engines provided performance consistency that German single-engine fighters, despite their individual engine quality, could never match. German technical evaluation, conducted too late in the war to matter, confirmed that the P-38's design philosophy represented superior understanding of modern air warfare requirements. May 1945 brought German surrender and, with it, comprehensive documentation of a Luftwaffe, devastated by American air superiority established through fighters like the P-38 Lightning. The post-war technical analysis, interrogation of German officers, and examination of captured documents revealed the complete picture of how German perceptions had evolved from dismissive confidence in 1942 to desperate acceptance of defeat by 1944. The P-38 Lightning, which began as an American design pursued in relative obscurity during the 1930s, became one of the war's most significant fighter aircraft. A total of 10,283 P-38 Lightnings were produced, with approximately 7,800 served with the United States Army Air Forces. The aircraft achieved 20,117 confirmed aerial victories across all theaters of operation, a record exceeding any other American fighter type. The strategic implications of American fighter superiority, achieved and maintained by P-38 Lightnings and later P-51 Mustangs, proved decisive in winning air superiority over Nazi Germany. This air superiority made possible the strategic bombing campaign that devastated German industrial capacity. The bombing campaign, unsustainable without fighter escort and protection, required exactly the capabilities that the P-38 Lightning provided: range, reliability, and performance sufficient to operate deep over German territory while maintaining combat effectiveness. This historical synthesis is documented in numerous official sources, including the U.S. Strategic Bombing Survey, the official USAF historical records, and extensively referenced in aviation historian Richard P. Hallian's The Path to Victory, which provides comprehensive analysis of air combat's role in World War II. German pilots who served during the war and survived to write memoirs universally acknowledged the P-38 Lightning as a turning point in air warfare. What began as underestimation transformed into grudging respect, and then desperate recognition that tactical skill, pilot training, and even superior individual aircraft mattered less than the combination of technical advantage, production capacity, and numeric superiority. The twin engines that seemed wasteful in 1942 represented the precise features that made the P-38 irreplaceable by 1944. The historical lesson extended far beyond aircraft design. The P-38 Lightning's dominance represented the triumph of strategic vision over tactical prejudice. American designers had correctly anticipated that future fighter warfare would require range, reliability, and sustained performance. German designers, bound by traditions of single-engine fighter design and prejudices against apparent redundancy, had failed to anticipate how air warfare would evolve. The consequence proved catastrophic: a fighter force unable to compete with enemies possessing both technical and numeric advantage. Major Adolf Galland, in post-war reflections, emphasized that German pilots bore no responsibility for their defeat in the air. The pilot of a Bf-109 or FW-190, flying against a P-38 Lightning formation with superior numbers and training, faced circumstances where individual skill mattered less than the systemic disadvantages that accumulated across technical, production, and strategic dimensions. German air superiority had been lost not through pilot deficiency, but through strategic miscalculation that failed to anticipate American technical capabilities. The P-38 Lightning's legacy extended beyond World War II. Post-war air forces examined the aircraft's design, studying how twin engines provided capabilities impossible in single-engine fighters. The insights gained directly influenced fighter design during the early Cold War, with aircraft like the Lockheed F-89 Scorpion and F-82 Falcon incorporating twin-engine configurations for specific performance requirements. The fundamental principle that redundancy and performance could outweigh the inefficiency of carrying two engines remained relevant long after propeller-driven fighters gave way to jet aircraft. For German pilots and engineers who survived the war, the P-38 Lightning represented a profound historical lesson about the relationship between technical design, industrial capacity, and military victory. The aircraft that seemed strange and unnecessary in 1942 had become, by 1944, the symbol of an emerging American supremacy that would define the post-war world. The twin engines that German pilots had initially derided as wasteful proved to be the feature that enabled the greatest range, most reliable performance, and superior capability to survive damage, exactly the characteristics that modern air warfare demanded. The historical irony proved complete. German pilots, flying individual aircraft as sophisticated as any in the world, possessed by training and experience that exceeded their American counterparts, were systematically defeated by an aircraft that represented a different philosophy about how air warfare should be conducted. The P-38 Lightning's twin engines, far from being a liability, became the defining feature of an approach to fighter aircraft that prioritized sustained superiority over instantaneous advantage, an approach that proved decisive in modern aerial warfare and continues to influence aircraft design into the present century.